Welcome to Homework Lib.
Which disaccharide, after treatment with CH3I and silver oxide, and then after hydrolysis, gives 2,3,4,6 tetra or methyl galactose and 1,3,4 tri or methyl fructose. And hydrolysis of that give 1 molecule of fructose and 1 molecule of galactose. D-fructose, D-galactose. Can be acidic hydrolysis or enzymatic hydrolysis, doesn't really matter. So first, let's write structure of fructose and galactose. For fructose, in those empty ends of lines, that means hydrogens, for simplicity. And for galactose, well, it can be anything here. Alpha, beta form, it doesn't matter. That's original structure. Now let's build structure of 2, 3, 4, 6 tetra or methyl galactose. So we start numbering from the glycosic carbon. 1, 2, 3, 4, 5, 6. And we replace hydrogen in those carbons with methyl groups. And same thing we're doing with fructose. We're numbering to assign the lowest number to the glycosidic carbon, which is 2, 3, 4, 5, 6. And we'll substitute hydrogens at those carbons with methyl groups. So let's erase. On galactose 2, 3, 4, 6 hydrogens. 2, 3, 4, 6 hydrogens. And on fructose 1, 3, 4. 1, 3, and 4. And replace them with methyl groups. And it's also known the disaccharide is reducing. And also invertase doesn't cleave it. So invertase doesn't cleave it. It shows there is no glycoside-glycoside bond. But it's same information as the sugar is reducing. Means one glycoside bond is not engaged in coupling. And actually, neither of those two pieces of information is important as long as you see structure of hydrolysis. Let's look at the galactose derivative. It has only one free OH group. This reagent, it does complete methylation. It methylates all available OH group. So now, why is this group not methylated? Two reasons. First, it wasn't methylated in the first place, and second, it was hydrolyzed under those conditions. It can hydrolyze only if it's glycosic. Those conditions are too mild to hydrolyze ethers. So that's the only OH group exposed. So this group was engaged in binding with the molecule of fructose. So now we need to determine which group in fructose engaged in bonding. So this OH group in galactose, it was released during hydrolysis because it was engaged in bonding, and it wasn't methylated in the first place because there were no OH group. It was engaged in the acetal. In the product of hydrolysis on the fructose side, you have two OH groups. One of them is glycoside, and another just an ordinary primary alcohol. So which group was engaged in binding with galactose? Glycoside wasn't engaged in binding there because that sugar would be non-reducing. Then why it's OH? It's produced in the process of hydrolysis. First it was methylated, and then it was hydrolyzed. But this group, it's primary. It wasn't engaged in hydrolysis. So it could not be released by hydrolysis. It means this group was not methylated. It was methylated. It means it was engaged in binding. It means this group wasn't present in the starting structure. It was engaged in binding. So now we identified the group which was engaged in binding. And now we can write the answer for the disaccharide. So those two monosaccharides, they were engaged by those two OH groups marked by the esters. Now let's just draw it. So there are different ways to draw it. We can start from fructose. That goes to the second galactose unit. And the rest of the molecule is just fructose. And here to connect to fructose, we need to flip galactose by 180 degrees. Means it would be carbon 1, 2, 3, 4, 5. And all substituents are flipped. So here, HOCH2, carbon 1 will be bound here. It could be other way, or alpha or beta. Both of them will give you same products of hydrolysis. At carbon 2, we flip up. At carbon 3, we flip down. At carbon 4, it's down. And at carbon 5, it's down. So here's the structure of the disaccharide in question. Now let's name it. I will free some space. So we start from the carbohydrate, which is engaged by its glycoside part. D galacto pyranozole. Because it's galactose in the 6-membered ring form, pyranozole. Then we need to show which atoms are connected, which is the glycoside bond. It's between carbon 1 of galactose and carbon 6 of fructose. And then it connects to this part, which is the D-fructose. So that's D-galactopyranacil 1,6-D-fructose.